Hello, dear professor. It's me again, Vahid Ranchwar. In this video, I'm going to explain how I done my assignment 3 for data mining course Milestone 3. First of all, before I explain the covariance analysis, I want to mention something. In previous assignments, we used Scrappy, we used Selenium, Beautiful Soup to extract our data from website. In this section, we have implemented another strategy to get our data. First, we intended to get more sources for our data set. So we get gas data, and gold data, silver data, and oil data from the market, and try to create relationship between these other sources and our stock data. To do so, as I said, we implemented another strategy to get our data set. How did we do that? If we select any website that includes our data, we can inspect our data set, especially when the website has a graph like this. This type of graph means that probably we have a historical data in the server that hosts this website. So if we can make a way to get access to this historical data, there is no need to actually crawl a bunch of web pages to get our data and load maybe thousands of web pages to get our data one by one. To do so, I have implemented this approach. I am inspecting this web page, and here, if I go into network, there's lots of pages when this web page is coming up. And if we look precise at this web page, we can find a link that guides us to our actual data. This is the link that actually a JSON file and that hold all of the data that we need for this graph, which is historical data. And if we can, as you can see here, this is from I don't know, this is for 1 day actually. But if we change this one, as you can see, we can select all the data that we need from this graph. And how? This is a JSON file, and this JSON file has this structure, which holds all of the data that we need: the date, the open price, the close price, the low price, high price. And if we can get access to this JSON file, then we simply can do some pre-processing and get our data. That's what we have done here. This is the actually the URL that give us that JSON file. I have opened that here. This is, as you can see, JSON data. This is our data, and if I expand this more, this is our clean data, and we can go through this one JSON file instead of more than 1,000 pages and get all the data that we need here. And this is another version of the same data, which is a dictionary of maybe our data, which has this key and a list of all the data that we need. So after finding this, we wrote a code, which is this one. This is the links that I explained earlier, and here I am requesting from that the server that hosts these links, that I am requesting and asking for this URL. It gives back me this URL, which is an HTTP format. I should change it to a string format, which is here. I have done it, and after that I would be able to create a JSON file, and after creating JSON file I would be able to simply go through all the data that I have in that JSON file and extract that and store it here using this function into my data set in MySQL. To show that this program is working, I am creating a test table here. I am using this database. There is no test table here. I'm creating it now. Yes, this is created test table, and as you can see here, I have no data here. So now let's run our code and see if it's working. It's done. It says that data is perfectly gathered and storing in our data set. Let me stop the code here, and yeah, if we rerun this section, yeah, this is our data. This is our complete data for which is include almost 4 gold data in. As I said, it is, I think, for 1 year. It's include more than 1,000 record. This is the way that we collected our complete data, stock data, and all of the other data and of the other sources that we need to do our correlation or covariance analysis. So after gathering all of the data, we imported our data into our Python environment. I'm coding this part in Jupyter Notebook. I'm importing all of the library as needed. Here I am reading all the CSV file that we have stored in our database and bring them here into our environment. This is a sample data from StockDF. If gas data frame, oil data frame, all of them looks the same. Here I am, because I want to work with time series, I prefer to have this index instead of just a number. I prefer to have these indexes as a data time variable. Okay, so I decided to make this column stock date here, and for example gas date, gold date, all of them are of type date time. So I decided to create an index of type datetime instead of just an integer, so it would be much more easier for further analysis later. Yeah, I have done it here, and after doing that, I just get rid of this ID number and again this stock date, because there is no need for this stock date anymore, and it's already in our table as index. Okay, I have done it here, and now this is our clean data set for analysis, for our analysis, which is stack data. Now I have a index of type data time, which is more easier to work with time series. Okay, okay, this is done here. After this step, I decided to study data from the third month of 2008 to third month of 2000, almost 1 year, just for the sake of simplicity. Yeah, this is the dimension of our data, 278 rows and 5 columns. Again. This is the oil data that I have here, and this is the format again. It seems like the same, so it would be much easier to analyze. Okay, to be able to do covariance analysis, I should be able to actually concatenate the related data in one table, not 5 or 6 separate tables. Okay, so here I am creating a new data frame which includes all of the prices for gas, for oil, for gold, for silver, oil, and stock data in the same table. So then I would be able to calculate our covariance much more easily. So I have done it here and here, yeah, this is our table: stock price, oil price, silver price, all of those data that was separate now they are all living in the same table. And here this is the part that I am calculating the covariance between different sources, between, for example, gold and I don't know, gas price, for example, or gold and silver price, stock price, and this is the calculation. As we can see, as we know, covariance shows the direction of the relationship between different variables, and not the value and magnitude of the correlation. Okay, here the gas price has a negative direction versus stock price, oil price, silver price. It means that if gas price goes up, then the other prices will go down. Okay, that's the meaning of the negative sign. But for gold, silver, oil, and stock, all of the signs are positive, so they are changing the same direction. And okay, so if gold price goes up, then the stock price, for example, goes up. Yeah, and for further analysis, I decided to calculate the correlation and the magnitude of this relationship between our variables, and that's what I have done here. And for the sake of observation and more clear understanding, I created a heat map that shows the magnitude of the relationship here. As you can see here, the paler the color, the stronger the relationship. Okay, so for example, each variable has a strong relationship with itself, which makes sense. And after that, the most powerful correlation is between oil price and stock price. And after those, silver and gold price have a slightly weaker correlation with the stock price, but still is considerable. And for gas price, as this part, which is the weakest on this scale, and there is a negative correlation between gas price and stock price. This is the actually covariance and correlation analysis of our data set, our data from different sources, from gold, oil, silver, gas, and the stock price. We are studying the relationship between those parts of the industry with the stock price industry. And the final step was to create a SACS diagram, which stands for, as I said, the symbolic aggregate approximation. And this is the code which you actually provided to us, and I have changed it. I have fed my data here, cost, which is this table. Yeah, this table, the final table for covariance analysis. And after running all of this code, I am getting this nice figure, which means that a slight descendant trend in our data.